Hello everyone, myself V. Krishnaveni, working as assistant professor from Marri Laxman Reddy Institute of Technology and Management. So my subject is applied physics. I am going to explain about Kronig and Penny model, which is there in the quantum mechanics for first year students. So let us go for the Kronig Penny model. So let us go for the first slide. So Kronig Penny model was proposed in the year 19th century. So this is the zone theory, one of the development of the free electron theory. So that is the first theory is the classical free electron theory, second is quantum free electron theory, third one is zone theory. So zone theory was developed by Bloch as well as Kronig and Penny. So Bloch was proposed the Bloch theorem, that is the potential the electron which is moving under the periodic potential in the solids. So whereas in Kronig Penny is also periodic potential, but here there is a square well potential instead of periodic potential. So square well potential in the sense which is constant in between the lattice ions or atoms, but which is zero at the nucleus or lattice ions. So Kronig Penny is the development of the zone theory. So now we'll go for the Kronig Penny model in detail. So which is proposed in the simplest form, that is potential is in the form of array of square wells. So square wells here it is, there are very array of very high number of square wells. So there are 1, 2, 3, 4, 5 square wells along the x direction. If the particle is a particle here, it is electron which is moving under square well potential along x direction. So here omega is the width of the potential. So this is the potential, square well potential. The width of this is omega. And the strength of the potential, that is V naught, high strength of the potential is V naught. So here A to A is the distance from one atom to another atom. So A is from the center origin to the first atom, it is A, second is 2A and so on. Similarly for the left side also, negative axis and positive axis. On y-axis it is the potential. So where it is the V naught is the highest potential and which is maximum potential, and omega is the width of the potential box or square well potential. So Bloch was proposed the theorem. That theorem is based on the electron which is moving under periodic potential, which is a parabolic shape. That is in between the ions the potential is maximum, and at the near the nucleus the potential is zero. So this is the Bloch. Whereas Kronig Penny, instead of parabolic, it is assumed the square well potential. That is the difference between the Bloch as well as Kronig and Penny. So how he was taken the conclusions. So what are the conclusions of Kronig Penny? How he has taken the assumptions by taking the square well potential. Now we will see. So whatever be the theorem, that is the development of the zone theory, that is entirely based on the quantum mechanics, that is Schrodinger wave equation. That is the Schrodinger wave equation is the development of the quantum mechanics. So Schrodinger wave equation for one dimension, we can well known equation, that is d square psi by dx square plus 2m into e minus v of x by h cut square into psi is equal to 0. So this is what wave equation in one dimension. So that is psi is, you know, wave function, m is the mass of the electron, m is the mass of the electron, and h psi is the wave function, and x is the particle is moving only along x direction. Next, E is the energy, that is total energy of the electron, and V is the V of x is the potential, that is square well potential. Square well potential. So next, m is what? Mass. Everything is over. Next, according to Bloch, so what is the Bloch solution? That is periodic potential. Same solution was taken by the Kronig and Penny. What is that equation? That is solution of this equation is psi of x is equal to e power ikx into uk of x. So where uk of x is, that is in the last class only we have seen, that is uk of x is modulating function, and k is a wave vector or propagation vector. Again x is the direction of the particle which is moving. So uk of x is the modulating function. So where uk of modulating function is also maintaining periodic, that is uk of x plus na is equal to uk of x. So if the particle is yx plus a, x plus 2a, x plus 3a, so n number of particles are moving, so na, so whatever be the particle number, the potential is which is constant, that is uk of x. So this is the solution of the wave equation, was taken by Kronig, similar to that of the Bloch theorem. So in this we have the two regions. So square well potential. Square well potential, in between the lattice it is maximum. In between the lattice it is maximum. At the nucleus or lattice ions it is 0. So in between, these are all in between. In between maximum, that is region 2. At the nucleus, region 1. So region 1 V is equal to 0. Region 2 V is equal to V naught. Region 2 V is equal to V naught. Region 2, region 1 V is equal to 0. For region 1 there is one equation. For region 2 there is another equation. So what is that equation? Substitute V equal to 0 in equation 1. What is equation 1? So this is the equation 1. In this, in place of V, write down the 0. Then what you will get? Only 2me by h cross square. So where 2me by h cross square is equal to alpha square. So next, region 2. Region 2 is V equal to V naught. So V is equal to V naught. If you substitute, then what you will get? D square psi by dx square minus beta square into psi, where beta square is 2m into V naught minus E by h cross square. So here in place of V, substitute V naught, again 2me minus V naught by h cross square is minus beta square. So substitute this entire length term is substituted into simplest form, that is beta square. So beta square, the equation is becomes to in the terms of alpha square and beta square, where alpha square is this and beta square is this. Next, by solving this equation, what is that equation? There are two second order differential equations. So one is this, d square psi by dx square plus alpha square into psi is equal to 0. Another second order differential equation is d square psi by dx square minus beta square into psi. By solving these equations, so these are all lengthy process. For our syllabus constraints, we have no derivation and we have written directly. By doing the solvation, we will get the direct equation, that is cos ka is equal to p sin alpha a by alpha a plus cos ka. So this is equation number 3. So where k is, you know, that is wave vector or propagation vector. What is V naught? V naught is a energy or strength of the potential, and omega is width of the potential. If V naught increases, omega, width of the potential barrier is decreases. Means the product V naught W is constant. V naught increases, V naught means potential strength increases, width of the barrier potential barrier is decreases. The product of these two is constant. One is increasing, another one is decreasing. So the product will be constant. That is here only the constant, which is remains constant. Next, it gives a terms in the solution in the form of this equation number 3. So where P is what? Scattering power. Where P is what? Scattering power. V naught omega is barrier strength. Barrier strength. Again, so what are the remaining terms? P is a new term, that is scattering power, and alpha is energy. The energy is 2 pi, that is alpha square is equal to 2me by h cut square. So this is what? Alpha is indirectly energy. So k is propagation vector and wave vector. So there is no solution for this. Directly we have written after doing solutions, that is there is no mathematical derivation for us in our syllabus. So that's why we have written directly. cos Ka is equal to P sin alpha A by alpha A plus cos alpha A. So, where P is the scattering power and V naught omega is the barrier strength. So, here in this equation number 3, what is the equation number 3? LHS cos Ka, RHS is alpha A. So, LHS is Ka, LHS having the cos Ka, RHS is in terms of alpha A. Means LHS is cos Ka. What is the lower limit of cos theta values? -1. Upper limit of cos values? +1. So, if the left hand side is from -1 to +1, obviously right hand side is also ranging from -1 to +1. So, equation 3 satisfied for only the values between +1 to -1. So, from these values only we can get the conclusions of the Kronig and Penny. So, what are the conclusions of the Kronig and Penny based on the values of P? Now, we will see the conclusions. So, first conclusion. So, first is the first conclusion, the energy spectrum of electron consists of number of allowed and forbidden bands. So, allowed band means the electron is moving. Forbidden band means electron is not at all able to moving, means which is a forbidden band. Electron moving means allowed band, electron not moving means forbidden band or not allowed band. So, see the graph here. So, on x-axis the values are alpha A, on y-axis we have taken RHS value, that is P sin alpha A by alpha A plus cos alpha A. What is the cos theta values? Upper limit is +1, lower limit is -1. So, what are the values? The electron which is moving only the between values between +1 to -1. That is, if the particle is moving, this is the allowed band. The particle is not moving, that is not allowed band. So, here the spectrum is consisting of a series of allowed and not allowed bands. The energy spectrum is consisting of what? A series of, one is allowed band, another one is not allowed band. So, here based on alpha A values are increases. When alpha A plus pi, 2 pi, 3 pi, alpha A's values are increases, allowed band width is go on increases. If the alpha A increases, what is happening? The electron have a free to move in the band, that is allowed band width is go on increases, that is the width is go on increases if alpha A is increases. And also P, if the P value, that is barrier, that is scattering power value also increases, what will happen? Allowed band width decreases and not allowed band width increases. If the increase of the P value, what will happen? The width of the allowed band values will be decreases and not allowed band width is increases. So, alpha increases, allowed is increases, not allowed decreases. But P increases, allowed band is decreases, not allowed band is increases. So, next what is the first conclusion? That is, this is the first conclusion, that is alpha A values increases. This is the first conclusion, alpha A increases, allowed band width is increases, not allowed band width is decreases. That is first conclusion. And second conclusion is, here also x-axis is alpha A, that is energy values of the electron, and the y-axis is scattering power, that is P on y-axis. So, what is the ranges of the alpha A values? +1 to again -1. So, when P tends to 0, that is second conclusion. This is what? Conclusion 2. So, conclusion 2 is what? When P tends to 0. When P tends to 0, what will happen to the equation number 3? So, equation number 3 is what? Cos P cos, what is that equation? Cos Ka is equal to P sin alpha A by alpha A plus cos alpha A. If P tends to 0, this value is 0, then what will happen? Cos Ka is equal to cos alpha A. So, this is the equation, cos Ka is equal to cos alpha A. So, indirectly Ka is equal to alpha A. Next, Here A gets cancelled, K square is equal to alpha square. K square is equal to alpha square. K is what? 2 pi by lambda. K is 2 pi by lambda. K square is 4 pi square by lambda square. Alpha square is equal to 2me by h cut square. So, after simplifying this equation, then what will happen? E is equal to p square by 2m, that is equal to kinetic energy. So, 2me by h cut square is replaced by h by 2 pi. Substitute h by 2 pi and rearrange the terms and simplify the terms, then you will get E equal to p square by 2m. P square by 2m is the kinetic energy of the electron. Means there is no restriction of the movement of the electron which is freely moving inside the solid, that is the conductor. It is the case of the conductor. Means there is no forbidden bands. No forbidden bands. Only allowed bands are there. No forbidden bands, only allowed bands are there for scattering power tends to 0. What will say the scattering power? Scattering power says the strength of the electron which is attracted towards the nucleus. That is, if it is 0, there is no electron, there is no restriction on electron. If it is in infinity, the electron is bounded with the nucleus. So that's why if the p is more, electron is not at all moving. If the p is 0, the electron is freely moving. So this is second conclusion. Third conclusion is p tends to infinity. So when p tends to infinity, again go for equation number 3. When p tends to infinity, this if the p tends to infinity, sin alpha a should be 0. If the p tends to infinity, sin alpha a should be 0. Otherwise, the value is infinity, undefined electron movement. So that's why if p tends to infinity, obviously sin alpha a should be 0. Otherwise, infinity multiplied by infinity will becomes to infinity. So that's why the condition on sin alpha a should be 0. When sin theta values are 0, for 180 it is 0, for 360 0. So for all n pi, all n value, n multiply integer multiple of pi will be 0. So theta value should be n pi. So alpha square a square is equal to n square pi square. Alpha square is equal to n square pi square by a square. Alpha square is 2me by h cut square is equal to n square pi square by a square. So E is equal to, write down this, n square h cut square pi square by 2ma square. Here h cut again replaced by h by 2 pi. Substituting h by 2 pi, in this equation you will get the n square h square by 8ma square. So what is this equation represent? Electron is bounded particle. The particle in potential box. Electron is bounded means electron is not moving. Not moving means which is a case of insulator. So that's why here it is so having only one line in this graph, because there is no in the range of +1 to -1. So that's why electron is a bounded particle. There is no allowed energy levels. No allowed energy levels. No allowed energy levels in this case. Only not allowed energy levels. Everything is forbidden. There is no allowed. So this is a case of insulator. This is conclusion number 3. So this is about the Kronig and Penny model. So this is based on this band theory or zone theory. The development of the zone theory was Brock as well as Kronig and Penny. So by using this, we have the classification of solids based on these conclusions of Kronig Penny. We have the band theory of solid, that is conductor, semiconductor and insulator, that we will discuss in the next class. So in this Kronig Penny, how he was assumed the potential, that is square well potential. In this there are two regions, region 1 and region 2. Region 1 is 0 potential, region 2 is a V0, a maximum strength of the potential V0. Based on this, we will get the two equations in terms of alpha and beta. By solving this equation, you will get one, that is cos Ka by is equal to P sin alpha A by alpha A plus cos alpha A. So, from this equation, we have the conclusion. If the P increases, allowed bandwidth increases, not allowed bandwidth is decreases. If the P value is 0, all are allowed bands. There is no not allowed bands. If the P tends to infinity, only not allowed band, there is no allowed band. Here, the P value is increases, what will happen? Allowed band value is decreases, not allowed bandwidth is increases. So, this is about the Kronig and Penny model and its conclusions. So, next class, we'll see the band theory of solids. So, this was referred by this book. Thank you.